In this screencast, we'll talk about our experiment on IS-free barcode localization recognition on mobile phones, and we'll start with a high description of our software that runs on Google Nexus One, which is an Android smartphone. So our IS-free barcode scanning solution is comprised of 4 modules: interactive camera alignment, barcode detection, barcode localization, and barcode decoding. First and foremost, why is that a problem? Because as we have presented various papers on IS-free barcode scanning, people always ask us, well, how come? I mean, isn't it a solved problem? And the question is no, it's not a solved problem. Because the solved problem is barcode decoding or barcode reading, vision-based barcode reading, when the camera is assumed to be aligned with the barcode. But in our context, since we're working toward an IS-free barcode scanning solution for visually impaired individuals in the context of independent blind grocery shopping, then that problem is far from being solved, because you can think of a surface on which a visually impaired shopper is trying to find a barcode, right? For example, could be a box, or could be a bottle, or could be a can, and then the problem is alignment, camera alignment. So the barcode has to be within the cone of vision of a mobile camera. And that is a very serious barrier toward independent product identification, right? Because to align the camera with the barcode is a very difficult task. So if you think of this as a surface, and somewhere on that surface there is a barcode, and then here's a phone, mobile phone with a camera, and then you can think of it as a flashlight. Right, so here's a flashlight, and it's looking for a barcode on that surface, and eventually, if there is a barcode present on that surface, so it's going to be within the cone of vision of the camera and will be identified. So this is very different from the commercial solutions out there that assume that the camera has already been perfectly aligned. So to illustrate how the system works, let's consider a typical case, right, of how the system is operating. So let's say that we have a visually impaired shopper who wants to scan the UPC barcode on the product. The very first step is to place the phone on the product such that the camera faces the product and aligns with the product. So here's a surface, and then here's a phone placed. If the product is a box, then UPC barcodes, at least in the US, are usually located on the bottom side of boxes, on the sides of cans and bottles. So if a product is a box, then the barcode will be located somewhere on the bottom side, and the user can align one edge of the phone with the corresponding edge of the box. If it is a bottle, here's a bottle, then the user can align the bottom edge of the phone with the bottom edge of the bottle. If the product is a can, then the user can align either the top or the bottom edge of the phone with the corresponding edge of the can. And so here's, if it's a can, then the barcode will be typically somewhere toward the lower end of the can. So once the product is placed on the surface and is aligned with it, then the user can slowly move it away from the product. And so here's a surface, and the phone can be slowly moved away from the surface, and the system automatically detects that the beginning of the move and starts a timer, which notifies the user to stop moving the phone once it reaches a preset threshold that can be manipulated, obviously. And the system now starts the barcode detection module, which takes images continuously in video mode and analyzes each image to detect the presence of a barcode. And so essentially now the user uses the phone like a flashlight, looking for a barcode on a specific surface. If the barcode is not found, then the user can switch to a different side in case of a box and repeat the entire procedure. Or it can also rotate the can or a bottle. If the barcode is found, the system starts beeping to let the user know that the barcode is present in the image. And then the system now starts the barcode decoding module, which tries to decode the barcode. And if the barcode is decoded successfully, it is read out to the user. Otherwise, the system starts the barcode localization module again to find the precise location of the barcode in the image and to segment it from the background image. So the barcode decoding module tries to decode the barcode in the localized image, and the system tries to decode the barcode in the original image as well as in the localized image to improve the chances of decoding the barcode. So the experimental setup of the experiment that you're about to see is very, very simple. So there is it's a lab study. So there's a table in our laboratory with a bunch of empty boxes and bottles, and there's one can. The can is actually full. And then there's a visually impaired individual, Sachin Pavitran, a good friend of ours who has helped us immensely over the years with various blind solutions. So here's Sachin. My rendition of Sachin. And he has a Google Nexus One with our software installed in it. And here's a research assistant. In this case, it's Ali Asghar Kutianawala, who's video recording Sachin's behavior, assisting them with picking up products from the table. And then internally, the software is keeping track of precision and time it takes to decode and find barcodes on various products. So that's all there is to it. And here's the experiment, and experiment is broken into segments dedicated to each specific product type. So we start with water bottle.
Hold it. Camera is focused. 0780001134002.
Now on to a box of crackers.
Move camera away slowly.
There's a phone alignment.
Camera is focused. Pitch down. Move camera away slowly. Hold it. Camera is focused. 0111110090775.
Onto a box of tea.
Move camera away slowly. Hold it. Camera is focused. Move camera away slowly. Hold it. Camera is focused. Pitch up. Move camera away slowly. Hold it. Camera is 01540004083.